Welcome to Accelerated Engineering. My name is John, and today I'm going to show you how to build from scratch a function that converts a text string to ASCII characters, or to ASCII values, using a recursive lambda function. So I'm going to get started. I need some reference material first of all. We're going to build up the reference material and then generate the necessary function. In my lookup table, I know that I'm going to need decimal values, something that I can index values by. I'm going to need the hexadecimal values, I'll use here, and I'm going to need the actual ASCII characters, whatever those may be. Now, I'm only interested in doing the first 128 characters of the ASCII table, but I'm going to turn this into a table. This will be useful for me later if I have this formatted as a table. It makes referencing things easier. In this column, I'm going to use a nifty little trick that I use in tables. Use a function that looks like this. It says if the row at this point is the top of my table, if row is equal to 2, this is going to equal to 0 because I need a 0 indexed function. And if it's false, then it's going to equal the cell above it plus 1. And what this does is it will increment through the numbers starting at 0 all the way down to wherever I decide the bottom of my table is. In this case, I need to get down to a little too far, to the value 127. That gives me 128 values. In the next column, I would like to take the hexadecimal value of that number, and Excel has that function built in, the function called dec to hex. Snag that. And then in this column, I'm going to take the, I'm going to generate a character, or a char, based on the value that I've got here. Because it's a table, it autofills in. Now, I don't like that value error, so I will wrap this in a if error function. Tell it that if there's a error, I just want it to throw an empty space. And because it's a table, everything updates. And this gives me all of the ASCII characters indexed by their decimal number and their hexadecimal number from 0 through 127. And that's all that I'm going to worry about for this one. Now onto the actual function. I'm going to say that my message is just going to be in like message. That's what I'm going to work with for the time being. Starting the lambda. I'm going to say equals lambda. The parameter that I'm going to have, and this will be the only parameter for this calculation, is my input message. Okay. Then there's going to be something that it does here. I'll close the parentheses, and I'm going to feed it my message in cell E1 right away, just because that'll be a thing. Check to make sure that the formatting is correct. Output's 1, everything's good. Okay. What are we going to do? Well, the first thing that I need here is I need this to have an exit condition. I know that I'm going to need to do this recursively because I need to loop through each character inside of my message. So I need an exit function, or an exit condition first. I'm going to say if, this will be the main function in here. If my input message is equal to, is not equal to empty, so if there is something in my input message, then I'm going to do something here. And if it's false, then I'm just going to return an empty string, basically. That would be the end of my function. Now in here, where it says do something here, I will have to do something clever to loop through my characters. So in fact, I know that in order to do something here, I'm going to say that that's the portion of my formula that converts one character to the correct hex code in accordance with the ASCII table. But then I need to append onto it the rest of the message that gets converted. So this is where I'm going to decide what my function is called and then call it inside of itself. That's how recursion goes, right? I'm going to call this function text to ASCII. You know what? I'll call it text to, let's call it ASCII text to hex. And I'm going to pass something in. I'm going to pass something into that. We'll decide what in a moment. Okay. Actually, you know what? No, because I know what I'm going to pass it. What I'm going to pass this function is all of the input message except for the character that I'm dealing with outside of it. So this one is going to be whatever's on the right-hand side of the input message, but not all of it. I want the length of input message less 1 because I've already dealt with one character here. So we're going to say length of input message minus 1. Close right. Okay. So what that will do is if my do something here deals with one character at a time and figures that out, then it will pass the input message minus 1 character down to the next level. And that should go down, 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 dealing with one character at a time until it gets to the end. When it gets to the end, it just throws a blank space and the whole thing stacks right up and spits out a final answer. So my do something here, you saw from the tables already, I'm setting this up for an XLOOKUP function. So I know I need an XLOOKUP. Let's get that out of the books. Here's my XLOOKUP. Okay. First thing I need is my lookup value. That seems easy at first, because what I would probably do is take the left-hand character of my input message and start using that for a lookup value. The problem is that I already know that XLOOKUP is not case sensitive, and I need this to be case sensitive. So that's a problem. So let's skip lookup value for now and instead go for lookup array. How would I get a lookup array that only returns or only kind of triggers on the exact case sensitive value that I seek? Fortunately, Excel has a function called exact, and it checks whether, well, here's the code says. It says it checks whether two strings are exactly the same and returns true or false, and exact is case sensitive. So I'm going to take that and say, well, for my exact array, what I should probably check against is, I can use this to generate an array of true and false values. In fact, that solves my problem. If I look for the one place where I get a true value by comparing my one case-sensitive character with an entire array of characters, then I've solved my problem. I've at least I've found it. So we're going to say exact. My exact is I'm going to take the leftmost character of my input message, just one character, and close that off. And then the comparison of it is going to be, well, I'm going to compare it to all of my ASCII characters that I've arranged in this table. And that shapes up to be a really nice reference built in there. Oops. Now my return vector, my return array, is just going to be all of these hex codes here, or these hex values here. And that should do it. So I've got a chunk, I've got an exit condition, I've got a thing that deals with one character and then appends a recursive layer all the way down. Yeah, that looks pretty good. Hit enter, and I've got a name function, or a name error. Of course that makes sense because this function doesn't exist yet. I need to make that function exist. I will copy all of the text of my lambda, Control C, and then there we go. Take it into the name manager, generate a new function, and we're going to call it, we have to get this exactly right, ASCII text to hex. And I'll paste all of that function into this bar here. Hit OK, close, and there we go. I've generated a series of hexadecimal values that convert message to hex. Now, let's check this first of all. First thing I'm going to do is let's go down to a character that we know, 0. Okay, we're going to convert this ASCII text to hex, convert the value 0, and see what it spits out. It should spit out 30, and it does. Okay, great. Let's check and see if it's case sensitive. If I tell it to equals ASCII text to hex of capital A, yeah, it needs it to be passed as a proper string. Then it returns 41, which is correct. And if I use a lowercase a, it returns 61, which is also correct. Now I haven't checked one with a letter for hex, so let's just check and make sure that that's working. Here's 5a equals ASCII text to hex for the letter Z, capital letter Z. 5a, perfect. That's working exactly right. Okay, message spits out this array. That's great. Now, if we wanted to, we could take this and cause it to differentiate between these letters a little bit more. We could add a dash between the letters and update our lambda function that way, if that's something that we wanted. I don't particularly want that, but I'll just show you how real quick. There we go. Close. It depends well on the end. I'm sure we could figure out a way to work around that, but that's basically how that would work. Anyway, that concludes how to basically from scratch write a lambda function that converts text to hexadecimal code in accordance with the ASCII tables. I think next time I'll write a recursive lambda that does the opposite, converts from a hexadecimal code over into a, converts over into just plain old text. And once I'm done that, I think I'll put this converter up online and available for download. So you can look forward to that in the next day or so. And of course, if you download it, then you owe me at least a like, if not a subscribe. Anyway, hope you're having a great day. Keep going.